Have you ever wondered who set the foundation for our understanding of the physical world? Enter Isaac Newton, a man whose name is synonymous with genius, a titan in the realm of science. Born in the year of 1643 in the small hamlet of Woolsthorpe, England, Newton's early life was anything but extraordinary. Raised by his mother after his father's untimely death, Newton was born into a world that was on the brink of the scientific revolution. Yet, in the quiet countryside of Lincolnshire, a young Newton found solace in books and the natural world. It was here that he began to question the world around him, laying the groundwork for his future discoveries. Unbeknownst to the world, this seemingly ordinary boy was about to embark on a journey of scientific exploration that would forever change our understanding of the universe. A humble beginning for a man who would revolutionize our understanding of the universe. In 1661, a pivotal moment in Newton's life occurred when he enrolled at the University of Cambridge. This was where his academic journey truly began, an adventure that would shape the course of scientific understanding. Studying at Cambridge, Newton was surrounded by an atmosphere of intellectual curiosity. It was here that he discovered infinitesimal calculus, a mathematical technique that would revolutionize the way we understand the world around us. With this tool in his arsenal, he could explore the depths of the physical universe in ways that had never been done before. In addition to calculus, Newton's time at Cambridge saw him delve into the world of optics. He was fascinated by the nature of light and colour, leading him to develop theories that explained the phenomenon of the colour spectrum and the behaviour of light. His experiments with prisms and light refraction are still foundational to the study of optics today. But perhaps the most transformative work to come from Newton's Cambridge years was his development of the laws of motion and universal gravitation. These concepts, which describe the movement of objects and the force that keeps us grounded on Earth, were revolutionary. They would forever change our understanding of the physical world and the cosmos beyond. These years at Cambridge were the seedbed for Newton's groundbreaking findings. The discoveries he made during this period would shape the course of science, laying the groundwork for centuries of exploration and discovery. In 1687, Newton published his most significant work, the Philosophiae Naturalis Principia Mathematica. Within the pages of this revolutionary book, Newton presented 3 laws of motion, laws that would lay the foundation for classical physics and continue to influence the field of physics even to this day. The first law, often referred to as the law of inertia, states that an object will remain at rest or move in a straight line at a constant speed unless acted upon by an external force. This law tells us that motion, or the lack thereof, is the natural state of things, and that it takes a force such as a push or a pull to change that state. Newton's second law of motion is about the relationship between force, mass, and acceleration. It tells us that the force applied to an object is equal to its mass times its acceleration. In other words, if you push an object twice as hard, it will accelerate twice as much. And if the object is twice as massive, it will accelerate half as much. The third law, often summarized as "for every action there is an equal and opposite reaction," describes how forces always come in pairs. If you push against a wall, the wall pushes back with an equal amount of force. If a bird flaps its wings downwards, the air pushes the bird upwards with an equal force. These laws, simple yet profound, transformed our understanding of the physical world. They provided the basis for many of the technological advancements we enjoy today, from the cars we drive to the satellites that orbit our planet. But perhaps more importantly, they taught us a new way of thinking about the universe, a way that values observation, experimentation, and mathematical analysis. They showed us that the world is not a chaotic and unpredictable place, but a world of order and predictability, a world governed by laws. The Principia, a testament to Newton's brilliance, forever changed the way we perceive the physical world. Beyond his scientific achievements, Newton also played a key role in the fields of theology and alchemy. His later years were marked by a broad range of pursuits, demonstrating the depth and diversity of his intellect. Newton served 2 terms as a Member of Parliament for the University of Cambridge, where he had spent much of his academic career. His foray into politics, however, was brief, and he soon returned to his scientific endeavours. In 1699, Newton was elected as the president of the Royal Society, a position he held for over 2 decades until his death. Under his leadership, the Society thrived and became a cornerstone of the scientific revolution. But Newton's interests reached beyond the world of science. He was deeply invested in religious studies, spending countless hours interpreting the Bible and predicting the end of the world. His predictions, based on his study of biblical prophecies, suggested that the world would end no sooner than the year 2060. Newton also had a fascination with alchemy, the precursor to modern chemistry. He conducted numerous experiments in an attempt to decipher the secrets of the universe, such as the Philosopher's Stone and the elixir of life. Newton's curiosity and intellect extended far beyond the realm of science, leaving a lasting impact on various fields. So, how does Newton's work impact our lives today? To answer this, let's take a look at the world around us. It's hard to imagine a world without modern technologies like satellite navigation systems, isn't it? Well, these systems wouldn't exist without Newton's laws of motion. They rely on his laws to calculate the precise positions and velocities needed for accurate navigation. But Newton's influence goes beyond just technology. His work laid the foundation for many scientific fields. Physics, for instance, is built upon his laws of motion and universal gravitation. Astronomers still use his laws to study the movement of celestial bodies. And mathematics, calculus, a branch he co-developed, is integral to solving complex problems in science and engineering. In essence, Newton's work has permeated every facet of our lives, from the technology we use to the scientific principles that govern our understanding of the universe. His contributions are everywhere. Newton's work remains as relevant today as it was over 3 centuries ago, reminding us of the enduring nature of scientific discovery.